In our daily lives, electronic devices have become indispensable. All kinds of services and applications rely on internet development, whether it is for games, video streaming, or AI recognition. The demand for low latency and high bandwidth networks is also increasing. Since various network applications continue to develop, the overall network architecture from terminals to the cloud must be upgraded to meet the demands. The development of wired networks also evolved from 1 gigabit Ethernet to 100 gigabit Ethernet. Although the increase in network bandwidth can reduce network congestion, the actual evolution is driven by the hardware. Therefore, optimizing the use of resources with the same infrastructure and adjusting configurations as required become key factors for data centers. Before we introduce DPDK, let's first learn about what data plane is. By separating the control plane, which manages the network, and the data plane in the SDN architecture, the network management is delegated to a controller software at the control layer. The controller behaves like a human brain, giving commands to network devices, which are like human organs in a flexible and unified way. By doing so, network devices can focus only on delivering packets. The centralized approach to network management will greatly improve network resources management and utilization efficiency. DPDK is a software development kit designed to handle high-performance packet processing situations with general CPUs. It includes user space libraries and drivers. In the traditional Linux system, when a packet is received by a network interface card, the network interface card will interrupt and notify a CPU to process it. The CPU will filter the packet according to its headers. Finally, the filter data will then be passed to user space applications. When number of packet per second is significantly increased, there will be many interruptions, causing the CPU to keep doing context switch. Consequently, the processing of packet headers will cause delays in the upper layer applications. To achieve high application performance, DPDK uses Pole Mode Driver and kernel bypass to accelerate packet processing. Pole Mode Driver solves the issue of frequent interruptions that cause poor performance. Kernel bypass skips the packet filtering process from the general system, so packets can be directly passed from the network interface card to the upper layer application in the shortest possible time. On the other hand, DPDK can be a waste of resources in general application situations. Pole Mode Driver will keep CPUs running when there is little traffic, and kernel bypass may make upper-level application development more difficult. In summary, traditional Linux network applications under normal circumstances can be developed with kernel's protocol stack, and the hardware resources can also be scheduled as requested by the kernel. By using DPDK network applications, it would cost more and keep CPUs occupied with low workload. However, with the data plane application, the traditional Linux network application will experience too many interruptions, resulting in too many context switches and reducing performance. The kernel's protocol stack will also cause unnecessary processing time and packet delivery delays. By allocating dedicated hardware resources, the DPDK network application can improve overall performance, and packet processing complexity will also be significantly reduced. Next, we will compare the performance of the packet generator in Linux and DPDK. In this test, we will use ANS 9A44F. The hardware details and software version will be shown on the screen. In a test using the same single-core CPU to generate and send network packets, DPDK showed great packet processing performance, especially for small packets. Linux can only provide 410 megabits per second speed, while DPDK can provide up to 10 gigabits per second. Portwell DPDK test sharing ends here. For more information, contact Portwell, your trusted partner.